For this video, you need your physics data booklet and a notebook. So let's start. This is topic 2.1, SL Physics. We are in motion. So we have here the Suvat equations. S stands for displacement, units of meters. Displacement is a vector. The scalar quantity is distance. U is initial velocity, measured in meters per second. For the SI, the scalar counterpart is speed. V, final velocity, SI unit, meters per second. The scalar value is speed as well. Acceleration is a vector, meters per second squared are the units. T, time value, that's a scalar, units of seconds. Note there are 5 quantities, but you only need 4 to solve for any of these equations. You don't have to memorize these. Please note that these are vectors, meaning we're going to follow the Cartesian coordinate system. Up is the positive y direction, down, negative y direction, to the right, positive x direction, to the left, negative x direction. If you happen to switch your positive values and negative values, that's okay. As long as you're consistent, you'll still get the same answer. Note that IB typically asks you for the magnitude of everything at the end. After you do these calculations with the correct sign, they ask for the magnitude of the final velocity, or the magnitude of the initial speed, or the magnitude of the acceleration. So it doesn't matter as long as you were consistent in your signs. The answer will always be given with a positive value if they ask for magnitude. So just so we're clear, gravity only affects the y direction, so all objects fall straight down, meaning the acceleration of gravity, which is given in the front of the data booklet under the fundamental constants. This acceleration of gravity affects objects only vertically. Note, I let go of a pin. It falls towards the center of the earth. It's just stopped by surfaces on the way. If I let go of a pin, it never just flies sideways unless I've applied some force to propel it sideways. Gravity is an acceleration in the y direction only, downwards. All right, let's review these motion graphs really quickly. We have displacement versus time. I have a quantity. Displacement is given on the vertical axis. It's a dependent variable. Time, the horizontal axis, it's usually the independent variable. Displacement is the quantity / the unit of meters. Time is a quantity / units of seconds. So the slope of this graph is the average velocity. It's not the instantaneous velocity. When we take slopes in this class, we choose 2 points on a line. Typically these points are spaced far apart, and I take the y2 value minus the y1 over x2 minus x1. This gives me the average velocity, or the average speed. If this was a calculus-based physics class, we could deal with any type of function, any type of curve, and then I could calculate the gradient, the tangent line, or the slope at a particular point on that curve. This would give me the instantaneous velocity. This would be the derivative of the function at this point, but we don't use that. We use this. So we get average velocities. So if I take the rise units divided by the run units, what are the units for this graph? So the gradient for this graph would be meter units divided by second units, and indeed you can see meters per second. All right, velocity versus time graph. Velocity is the quantity / units of meters per second. Note independent or dependent vertical axis. Along the horizontal axis, again, we have time. The slope is the average acceleration. So again, to prove this, really any area. Oh, by the way, what's the slope of a horizontal line? It's 0. Okay, so the units would be meters times seconds per second for the gradient. Meters times seconds to the -1 per second times seconds to the -1 meters per second squared. We will need to calculate the area under the curve. Now the area under the curve is the change in position. Change in position is known as displacement. So what do I mean by area under the curve? You trap the region between the line graph and the horizontal axis. That becomes the area. All of the areas you will calculate are easy shapes because we don't integrate functions in this class. You'll deal with squares, you'll deal with triangles. Remember, the area of a triangle is half that of a square, 1/2 base times height. So, even for negative velocity values, negative velocity means the object was traveling at some speed in the negative direction. You trap the area between the line graph and the x-axis. What are the units for the area under the curve? Take the units of my vertical axis, I multiply by the units of my horizontal axis. For the area under the curve of my velocity versus time graph, that is meters times seconds to the -1 times seconds gives me units of meters, same as my displacement units. Then we have acceleration versus time graph. We will not deal with the area under the, we will not deal with the gradient of these graphs. The reason being is that the gradient or the slope of acceleration versus time is jerk, and we don't need that in this level of physics. Instead, we focus on the area for acceleration versus time. The area under the curve is the change in the object's velocity. Change in the object's velocity. So what are the units for the area under the curve of this graph? Okay, that's all that I have for you. Thanks for watching and study well.